It's almost now 7:10. We have to start our session, right? And we have another class after continuation of this training. And before what is the agenda? I think our director also joined. We know that how much pain we are taking regarding this product batch. And in this time also, thankful to our director sir can came to join and give some motivation and about your training and all these things. And the agenda, guys, I received a lot of calls and concerns from the students as a COVID situation, sir. We are unable to pay 10,000 for registration initially. So, sir, we are interested. A lot of students through counseling and Suntech team given an remarks of yours, and maybe I got a personal window charts and all these things, and spoke to the management with the help of director sir and all these things. Guys, today onwards we are starting the product-based training. As you know that. Guys, entire this product batch has been given to the Suntech team, and this 1 week training will going on to all the students, those who are interested and eligible. I mean to say that, and the entire the criteria of selection and all these things taken care by the Suntech team, and they will shortlist you in this week. They will shortlist you in this week about your performance and all the how you are scope up and how you are listening the classes and how you are regular to the attendance, and everything will count. They will monitor your performance, and according to that they will shortlist and you will forward to the next level of batch trainings. Are you getting my point, guys? Again, I am repeating, this 1 week is entire for all the students. Can attend. All interested and eligible students come and attend the training. Inform these things to your all your those who are there in the Suntech team. Inform them and convey this message. And after this week, they will shortlist the students and they will form a batch. And for this, from the management side and college side and all these things, I have to convey one message to you. After selection of you, only one thing is to say that initial registration you have to pay only 5,000, because that is for nominal consideration. I taken your all the family conditions in this COVID situation and the financial crisis and all these things we have taken into the consideration, and for that we came to the solution that at initial registration is 5,000, of who not everybody are not to pay. If you are not eligible and if you are not scope up also, we will not take. That the reason is not collecting of money, right? The reason is we need to be in the competitions, right? Only we have to generate one product batch. Already we are late, but not too late. We have a companies are in the pipeline. You know that yesterday some 8 CGPA candidates got the Informatica, and some companies will have no percentage. Some companies, I am into know all the companies, some companies will not consider you about your CGPA. They will consider your performance, and those companies we will forward to your names also. So guys, I'm requesting to everyone, participate in the training, be honestly participate, do the hard work and all these things, and we are there to place you guys. Again, I am saying that this 1 week is a free. All the students can attend. After 1 week, they will shortlist the students by the Suntech team. Those shortlisted only have to pay minimal registration 5,000. After that, the training will continues going on. No need to worry until the completion of training ongoing. Once you placed, in a product company, maybe you'll get an internship, right? Internship, at the time of internship, once you got the offer, at that time we will convey the amount to pay, reverse pay. We are not bothering about you, right? At the time, those who are selected and all these things, you have to pay to the college. This lenience is given by the thankful for the management, because lot of considerations are came, so we came to this solution. After your selection, and you have to pay to the amount to the college. That is right. So guys, now I'm giving to our director sir to address these students.
Good morning, everyone. I am audible.
Yes, sir.
Yeah, good morning once again. So, as already Madhav mentioned very clearly, what has been happened in the last 1 week, a lot of discussions went between us and between management and the Suntech Corp, and yesterday also. And our chairman, we should be thankful to our chairman finally coming into the picture and made it rather possible. That is what sir is only 22. When Suntech is initially told that only 22 students are ready to pay and they are eligible, then he thought that is not the way. We should extend and we should encourage all the interested students in spite of their financial problems and other things, because we should aim at least 90 students who are capable of rather achieving 6 lakhs and above. So that is the reason why the management has come down and they accepted for initial payment of only 5,000, and the rest is taken care rather by the management, and you can reimburse when you get a offer. So that is the final agreement made between. But anyhow, we will be paying in advance to the Suntech Corp as per their MOU whatever we had with them. So that is the reason why again the training is extended to again assess you once again, to assess you whether you will be capable of taking hold of this particular product training or not. That is the reason Suntech has come forward again to go for 1 week extensive training on the product training, so that after the 1 week they will assess again. And for that, you need to do is that you attend the classes regularly and be attentive and be focused, and you learn whatever they are going to teach you, and finally you try to see that you will be in the first list of the product batch. So all around 140 students have been there, including all the officials. Maybe 135 students are attending this. So you can this facility is extended to all the students, not only you who are attending, who are already a member of the Suntech of training. All are eligible. You can also inform them. But final criteria for the selection into the product batch will be purely based on your eligibility criteria. That is attendance for this particular week, performance, and also aggregate whatever you need to possess for the product companies. So based on all these factors, once again you will be assessed and you will be kept into the product batch training, wherein you have to register with 5,000 rupees by paying it. So please don't look at this 5,000. It is a token amount to make you serious, nothing else. Yeah, I can allow you even everybody into the Suntech product training, but the final agenda is that you must be capable of rather be interested in learning, as well as you have to be more focused, and you should aim it more than 6 lakhs package, and that is the reason why we kept that minimum registration fee. So that is the reason, and don't look at the registration fee or after that what happens. Everything is purely depends on your performance, and purely the attendance and other things. And not only that, we will take when you got job offer only, we will you need to reimburse the remaining amount. That will be in due course. Don't worry about all those things. So you please convey this message to your parents. You convince them once you have going to be there in the part of the list of Suntech IT product training batch. And also inform your friends who have some apprehensions. Maybe because of the reason, some of them may not be joined this session, but you inform them to attend the session because it is free now for all, open to all forum. So you can just go through it. You can also assess yourself. You can also assess the kind of training which they are imparting. So many other things also you from your side also you will be knowing, and from the Suntech Corp side also they will be assessing you. So finally, we are expecting finally at least 90 students from this particular batch will be able to achieve 6 lakhs and above. That is the yesterday chairman sir set a goal to us, and hopefully, because why so much discussion, so much instruction, so much information is going on all these days, because of the reason is that you are very clear that in the first two encounters you could not, rather nobody could move into the next stage. That is the reason we are more worried about your batch, 22 batch. Even 21 batch, without product training also, one of them got 11.5, few of them got 6 lakhs. So maybe, I think to my knowledge, 30 plus students, they got more than 6 lakh packages. And all of them, they could at least, in every company, 2 or 3 people are there. But this time, unfortunately, so far, 3 companies which have come forward, but nobody is listed in that. That is a major concern for us. That is the reason why we are more insisting on this particular IT product training. Otherwise, it would have things would have been differently. So that is the reason we don't want to let you down. We don't want, because for the last couple of years we got 30 plus product offers, but this, in the beginning itself, last 2 years back only, we set a goal that this batch should get 60 product offers. But while looking at your performance, while looking at your the latest performance, we are very worried, and certainly something has to be done for you to bring you into that line. That is the reason, for the last couple of weeks, maybe 1 month, we have been working out on this particular product training, how we should go. A lot of thinking has gone, and finally we arrived at. But after your response and after your concerns, considerations, everything, again we have come down. And to make you serious, that is the only reason. Otherwise, would have been kept free, and everything can be paid only once you get an offer. But only to see you, make you seriously, that is the reason we kept only 5,000. So please, my dear students, don't look at the interest of the Suntech Corp, or don't what is the interest of the institution or interest of the director. No, ultimately you are going to enjoy the fruits whatever you are going to achieve, not nobody else. Only we keep you rather in front, on the notice board, or maybe on the website. Only that purpose we are aiming to make, rather to keep our CMR technical campus flag high as ever. That is the only reason. We don't get anything out of this, all these activities, except you will be placing in a better company, you will be exposed to a better company, and finally you can settle in, um, rather you can lead a good life in your career. That is the main reason. So please take it seriously, and take it individually. Not, don't think of who has got an interest in that. So let us keep all these factors aside and be focused for this 1 week. And whoever could not make it in the first round into the IT product training, hopefully they can also cope up. And it is only a time mind game. Rather, if you say that your will, then definitely you will achieve. So with this, I wish you once again all the best, and inform all other your friends also who could not make it today because of any reason it may be, and take forward to the next level. Wish you all the best. Good luck for all of you.
And thank you, sir, for your message. And guys, my dear students, that is the way we are doing, guys. And majorly, guys, the companies are in the pipeline. Again, I am saying to everyone, we are taking the performance wise only. Sir, my name is not already. You told you that some of the students are calling to us and all these things. Right? Some companies maybe restriction will be there at the time. This notch will be used. Anyhow, our aim of this what sir said that minimum 60 students, 60 plus or 90 plus students have to get 6 lakhs and above package. That is the aim we are going to keep for this batch. And for this, you need to get the success. Your hand is compulsory. Without your hand, we cannot do all these things. Guys, wake up. Don't go into the lazy mode. Already time is gone. 3 companies gone. Already 4th company also gone. Now we have another more companies are there in the pipeline. Still we are not late. Concepts wise, you have to pick up very fast. Again, I am saying their strategy as different by Suntech team. They will explain you all these things. Those who are a very fast pickup, they will take into another tier 1 and tier 2, right? In this way the trainings will going on, guys. Utilize this opportunity and get the good job and get good package and good companies. And we are try our best to connect our alumni also, and we'll get some resources, right? Whatever you need. And let me know your queries in my personal window, or else anybody, your mentor and your coordinator or your HOD, call to them directly, whatever your concern is there. And we will clarify as much as soon as possible at that time in terms of training. Honestly, I'm saying in terms of training, if you are not cope up also, see it. If you're not able to cap up, leave it, not it. But honestly try it and get the good job, guys, right? And thank you, sir, for attending this session. And over to the Suntech team now. Thank you, sir.
Thank you, Mala sir.
Hmm.
Thank you,
Yes,
Director
sir.
sir.
Yes, sir.
Uh,
Thank you, sir.
Can you just confirm, am I audible?
Yes, you are audible.
Thank you. Sir. So, guys, as we have been, working about forming a batch for IT product and taking up the training. You all know that, what were the efforts? The efforts were to, initially conduct a pre-assessment, identify some students. We have identified 71 students given to the college, and then we have told that these guys are trainable. And then we have conducted one orientation of basic DS algos for tier 2 product companies jobs, and followed by 2 sessions where you can have an understanding about how the training is going to be. The objective was to make sure that if you are not able to catch up that level, you can drop on your own and you can get an understanding. And the objective from our end was to understand whether who are the students who can catch up and all. So that's where we have done one round of our activity with orientation and a couple of sessions. Then it has come to our notice that a lot of students have got the pain. So I myself have interacted with a lot of students, more than 100 students in a day, with a slot of half an hour with 6 students and all. And noted the remarks of what is the situation of students. I have found majorly a lot of students who are trainable, but they have uh, not a right situation to make the payment. See, I'm not talking about the position of the student's family, because I respect everyone's position. But anyone may have a situation to financially not pay at some point of time. So I have understood that most of the students had this difficult financial situation to pay. So I have noted down as a remark, and I have passed on those remarks to college, Madhav Rao sir and Raj Reddy sir, and they in turn also have got a lot of requests from students and parents about this thing. So collectively, all of us have conveyed this, and this all the all these challenges were conveyed to management, and management, I believe, yesterday had a discussion and said that they have asked, they wanted to invest, as Madhura said and director sir said, and they when they decided to invest, and they said the students must have the accountability and answerability. So they should not be completely given free, and hence they have kept a minimum registration fees of 5,000. I believe I've just come to know when Director Sir and Madhura Sir is talking. So you just think about this, guys. This is what we can do from our, because we wanted all the potential students who are trainable and eligible to get trained and get placed. You all are our students, and we always think in the you know as a well-wisher of you guys, where you can definitely become prospective. So I think now we have an agenda. The agenda is, they asked us to allow all the students. Now, earlier already we have 71 students who are shortlisted, so that is already there. And in those 71 students, if there are anyone who have difficulty to even register with 5,000 and all, you guys have to talk to the college. But the others, who are not shortlisted, uh, because around 300 students are there. So all these guys, they can undergo, because that time, the orientation and a couple of sessions are organized only that 71 students. So college is asking us to expose all the students to this kind of training. So this week, which has 3 sessions, Monday, Wednesday, and Friday. So all of you guys will be exposed to these sessions, and based upon your attendance, participation in this week until Saturday. So until Friday, Monday, Wednesday, and Friday are the sessions for 2 hours per day, 7 to 9 a.m. in the morning. So based upon your attendance and your performance, your participation in these 3 days time. So, and we may also look at how you are interacting with the mentor. So you all have mentees. So based upon all these things, we will shortlist some students for interviews on Saturday, and they would undergo interviews. And on Saturday night, we will give you a list of, we'll give the college a list of students who are trainable for 2 categories. One is, trainable for tier 1 product companies, which are for 10 lakhs and above package. So the level of the training would be high in that. And the next is tier 2 product companies, that is basic DS algos. So first one is basic DS algos, and the second is advanced DS algos. So we will identify students who are trainable by Saturday night, with interviews on Saturday, and also your participation in this week. And that list will be given. And next Sunday, your tier 1 product companies training, which is advanced DS algos, will start from 11 a.m. to 1 p.m. and 2 p.m. to 4 p.m. And they'll again have on Wednesday 6:30 to 8:30 p.m. And basic DS, they will have 3 days a week. From it will be continued next week also. But this week, all the students, interested students, can attend. But on Saturday, when we conduct assessment and look at your participation and all, looking at all your parameters, we will arrive at a list who are trainable, and those students only will continue from next Monday, next Sunday, in fact, for advanced DS algos from Sunday, and basic DS algos from Monday. So they'll continue. The others have to continue with the IT services that is happening. So it again, the batch will be decided purely based upon the trainability of the students. Okay. So we give this 3 days as an opportunity, or this week as an opportunity, to understand the level, and also work hard and try to catch up that level, so that you come under the trainable category. So this is the agenda, and we tried our best to make sure that management definitely facilitate more number of students to participate in this program by coming forward to address the challenge of payment in this COVID situation, which is a difficult thing for most of the students and their families. So I believe this is helpful to the students, and please try to have a good participation and performance on Saturday, and please try to catch up. And one important point I want to tell students is, see, trainability is the most important factor of trainability is, you should be good at logical thinking. And for a problem, how do you arrive at a solution? What is your approach? Do you have multiple approaches to a solution? With your logical thinking is the primary qualification for product company. Second is, can you optimize that code solution? And all this come under problem solving. That is the first aspect. Second aspect is, are you good at coding? Can you code? Can you code at least programs and all with one of the programming language? And third is, are you good with DS algos, data structures and algorithms? So these are the three things that we look at. And if you are good in these three things, good, not even good, if we find that yes, you are up to some extent and you can be trained and nurtured, then we'll definitely take you for the training. So use this 1 week's time to upgrade yourself. First of all, understand and upgrade yourself and meet these requirements and get ready for the training. Thank you, guys. Thank you very much.
Okay, thank you, sir. Thank you, sir, and all the best, guys. And we will see you very soon on Saturday with our product batch. Follow the instructions and of all the things. If anything, you let me know. Let me know with your mentor. Anyone who are comfortable with the, let me know with your personal chat window. All these things, we are there to help you in terms of anything, right? Thank you, sir. Thank you, director sir, and Venkat sir, and all these things. And over to the training. Thank you.
Hello.
Recording in progress.
Hello, guys. Good morning. Okay, so let's start the session. So if you remember the last session that we conducted, we covered the topics of arrays and strings. So today we will start searching, and later in this week we'll cover sorting. Okay. Let me know if you can hear me, and let me know if you have any questions for till now regarding the course, regarding the session. Okay. Okay, I'm sharing my screen. Let me know when you can see. Can you see my screen? Okay. So today we'll cover searching. Most of you might already know, but we will still understand why and how it is done. And then we will cover a few questions on it. Let me. Okay. Okay. So searching. Okay. Tell me why searching is needed, or what is searching basically. Searching in DS. So searching is not any specific data structure. It is just an algorithmic approach. Okay, so in a given data structure, let it be anything linear or non-linear, array, strings, linked list, graphs, queues, whatever it is. In every data structure is nothing but we are storing the data in a particular order. Okay, that is not storing data in structured order. So once we are storing it, we have to retrieve it. Correct. So if we just keep storing data, that doesn't make any sense. we have to also get the data, retrieve the data, right? So in retrieval part, we have to search it. So let's say if I am storing 100 student records, at some point of time I may need to search one particular student, okay? And this searching algorithms is nothing but it defines how we can search that particular student, okay? So few data structures allow us some structured storage where retrieval is kind of easy, okay? But let's say we want to search the entire data set. In that case, searching is helpful, okay? So let's talk about searching. So first we'll have linear search, and then we will have binary search, okay? These are specifically in respect to arrays because in binary tree and BST and all, searching varies, okay, depending on how the data structure is laid on, okay? So mostly for arrays, we will have these two kind of search. This can also be done for strings as well. Strings, again, if you consider it is just a character array, so if you want to do a search, you can do string. So more or less these are just an algorithmic approach, okay? You can implement binary search in other questions as well, okay? This is not just a searching thing, but also a algorithmic approach. So this binary search is a kind of a idea or algorithm where it divides the array into half again and again. So we will see how it does, okay? So let's start about linear search. Let's talk about linear search. Can you guys tell me what is linear search and why do we need it? Put your messages in the chat so that I can go through them. What is linear search, guys? So linear search is simplest of all, simplest searching algorithm. So let's say we have a data set like this. 1, 2, 0, 5, 4, 3. Okay, now I have to find out 4, okay, whether I want to see whether 4 is present in the array or not, okay? So this is the simplest and the brute force approach for any searching searching any data set. So we linear search is nothing but we traverse through all the data elements, okay? So in an array we can traverse based on indexes. So we first cover 0th index, then cover first index, then second index, then third index. Similarly, we keep on searching till we get the element, okay? This is a very simple algorithm, but it is a brute force approach for all the data sets, okay? So this searching algorithm can be blindly implemented for all the data structures and it will work. So now let's talk about the time complexity. So how this algorithm is. So what will be the time complexity of this algorithm? Okay, so you see now that we are searching for 4, we are going how many times? 1, 2, 3, 4, 5. We are going 5 times. That means nothing but we are executing 5 lines of code. Okay, but if I'm searching for 0, it will execute 3 lines of code. At the same time, if we search 3, we will execute for 0. It went 3 times. For 4, it went 5 times. For 3, it will go 5 times. 6 times, okay? So if you see, this number of executions are not constant, okay? So the best it can take is this thing, okay, order of 1, that is order of 1, and the worst it can go is order of 6. 6 is nothing but n, 0, n, okay? So, and as we know, whenever we are calculating time complexity, you have to go the worst case, okay? So the time complexity of this algorithm will be order of n, where n is nothing but the number of elements, and the best will be order of order of 1. If you're finding the first element, we will get it in order of 1. That's fine. Okay, but in time complexity wise, we only discuss the worst case scenario. Mostly we discuss the worst case scenario. Okay, so why linear search? Linear search is needed for searching because it is a brute force thing. So whenever a problem statement is given, first think of brute force solution. So whenever a searching problem is given to you, the brute force solution is linear search. Let's quickly see the logic, though it will be a simplest logic, but still. Okay. Okay, let me create an array. Meanwhile, if you have any questions, you can post them in chat. I'll be going through the chat every few minutes. Okay, then I've taken my array and just printing it out. Okay. Okay, let's try this out. Let's say 7, 5, 4, 1, 2, 6, 7. Okay, so we are successfully taking this thing. So now we have to let's say I want to search the index. So I will just write a normal function, find index. So the question is, you have to find the index of the element from the array. If the index is there, if the element is found, then you have to return the index. If not, you have to return -1. Okay, simple question. Int target. So I can just simply say also not needed. Int I is equal to 0, I less than. If I is equal to target, return I, else return -1. Okay. Let me take the number. So I'll call the function find index of ARR comma K. Okay, so let's see. Now I'm saying I'll find 6. So finding 6 found at index 4. Let's say 5, it will say index 0, and let's say 7, it will say index 6, because 7 is the length of the array, so 6 is the last index. If I give any other number, it should say -1. Okay, so the question is, so our program is working fine, and we are able to check whether an element is present in the data set or not, which is nothing but searching. So if you see, we are using a iterative approach where we start from 0 and we go to the last element till the and then we are just comparing it. Okay, so this is become this approach becomes an approach where the time complexity is order of n. Okay, why? Because we are bounded to the length of the array. Okay, so let's talk about the different next approaches, that is binary search. Any questions in linear search? Any questions, guys? Okay. Okay, now, binary search is another searching algorithm wherein it works only on sorted data set. That is the first thing that you should remember, only on sorted data set. Only on sorted data. Okay, so this is a add-on to linear search, where in linear search we were brutally going through all the elements. Binary search will make some smart decisions. Okay, let's see what these smart decisions could be. Let's say I have an array. Okay, so let's say I have an array which is sorted 1, 4, 5, 7, 8, 9. Okay, so now I'm searching for, let's say 5. Okay, so in linear wise we will go like this. Okay, we compare first element, second element, third element, and we'll get the value. Okay, but in binary search we will not go like that. Okay, we will start with the middle value. Okay, let's say the middle value is this thing. Okay, middle value is nothing but the 0 index plus the last index, which is nothing but 1, 1, 2, 3, 4, 5. 0 plus 5 by 2, that is 5 by 2, it is 2.5. So it will be 2. So index 2. So now in binary search, we will start looking with the middle index. Okay, now here the starting is this and ending is this. That means my 5 is expected to be in between starting and ending. So we will compare with the middle value. So now middle value is 5. Okay, let's say now we are searching for, let's say 8. Okay, so we are searching for 8. Okay, my middle value is 5. Okay, so what can we expect? So my mid value is 5. Okay, that means all my values less than on the left side of 5 will be less. That is for sure, that we know, because my array is sorted. Okay, that's the trick here. So if my array is sorted, when I compare my mid value, if my mid value is less than the target value, that means all my value in my left side is nothing but not required. My element will not be there. So we can just skip this entire searching part and we will only search this part. Okay, so now when I search this part, 3 plus 5, 8 by 2, that is nothing but 4. This is the middle value. Now you see, now middle value is equal to target. So I'll just simply leave it. Okay, so I'll simply return 4. But if the target was 7, okay. So now my mid value is greater than target. Okay, so my mid value is 8, but my target is 7. So 8 is greater than 7. That is nothing but my mid value is greater than target. In that case, I can simply skip this entire array. Okay, whatever it is on the right side, because I know that whatever elements on the right are greater than 7. So I can just simply, and I'll continue my traversal. So in binary search, we are dividing our search range by half every iteration. Okay, so that's a trick here. So and when we start moving, so this will start, this will be end, and we will find 7 and we will return the 7 value. Okay, so this is how binary search works. So we take a sorted array, we check the middle value. If the middle value is less than the target, that means my target element would be on the right side. Okay, and then we continue on the right side. If my middle value is greater than my target, then the middle value will be on the left side. Okay, depending on this, we will take our decisions. So here we have to make some decisions based on the middle value. That is the main thing. Okay, so tell me, what will the time complexity of a binary search? So in binary search, how many maximum times the logic will run? So if you see my array like this, okay, so this is my starting. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is the middle value. Okay, this is done. So that means one time I'm doing. Then let's say I'm coming here. I'm here. Second time I'm doing. Then let's say I'm going here. Okay, 6, third time, and then fourth time. Okay, maximum 4 times we can do. For an array of size 8, we are doing for 4 times. So is it n by 2, or what is this relation looks like? Okay, so let's see. So this will not be n by 2, guys. So for this array, it might look like it is going till n by 2, but it will be actually log of n. We will see how it is log of n. So first let's write the logic, and then we will see the time complexity. We'll have a quick discussion on the time complexity. So I will say public static int find index int arr. Let's name it binary. Okay, so we will say int low is equal to nothing but 0, and high is equal to my last value arr, that is my last index, arr dot length minus 1. Okay, so this is done. So now I will write a recursive iterative logic while my low is actually less than or equal to high. Okay, these are the valid terms. Okay, let's say while recursion or while iteration, if my low is here and my high is here, this is a false case, right? So low should always be less than high. So this is what we are checking here. Low is always less than high. Okay, then we are calculating the mid value. Let me say mid is equal to low plus high by 2. Okay, so now we are deciding if my arr of mid is equal to target, just return mid. Okay, else if arr of mid. Okay, so now we are doing a decisions part. Okay, focus attention here. Okay, if my middle value is greater than my target, okay, so then I have to search what I have to shift my low and high pointer. In this case, my high will be mid minus 1. Why minus 1? Because mid we have already considered mid is the element is not present in mid, so we can just decrement a pointer. Okay, else low is equal to mid plus 1. Okay, so if my arr of mid is greater than target, so I am decrementing the high pointer. Okay, that means I'm checking in the left side now. If not, I'm checking in the right side. Okay, it will continue till this condition fails, and if it didn't find, we will say return minus 1. Okay, that's it. So let's execute this logic as well. It's a binary. Yeah, so 100 is not found. Okay, first of all, it should be sorted. So let me give it in sorted order. 1, 2, 3, 4, 5, 6, 7. Let's say I'm searching 3. Yeah, 3 found it 2. 1 found it 0. 5 found it 4. Okay, so it is working fine. So now let's see how many times this logic will work, and let's calculate the time complexity. Okay, so for 0, 1, 2, 3, 4, 5, 6, 7. Okay, let's consider this array. Okay, what is the middle value here? 4. Okay, so this loop, so whenever I'm saying that it is executing, I'll just write. Okay, so first time I compare with 4. Okay, this is my first iteration. I didn't find, let's say I didn't find the element, so let's say I'm moving on the right side. Okay, and then my bound will be this thing. Okay, I will be searching in this part. Then let's say in the second iteration 6 is my middle value. Okay, so now after 6, whatever value is there, so let's say in the third iteration it might go 5 or 7. Okay, but in fourth iteration it will fail. So this is the number of times it is executing. Okay, let's increase the array element, so let's say 8. So again, for this array element of 8, my first search will be with 4. Okay, this will be my array. Okay, this will be 4 will be my mid value. For second iteration, this will be my value. For this 6 will be the mid value. For third, let's say I am moving on this side, so 7 will be the value, and let's say for fourth it will be 8 will be the value. Okay, so in this case, if you see, we are going, but if this array is growing, the logic will also grow, or the time complexity will also grow. So we need a formula which can help us understand how is the time complexity. Is it n or is it n by 2? Okay, so we will see that. So now let's discuss about time complexity a bit, so that you can understand how is it log n. Okay, so let's talk about time complexity. So then time complexity also, there is linear time complexity, there is logarithmic, there is quadratic, okay, and then there is exponential. Okay, so these are the 4 things. Okay, so now let's talk about linear. A linear time complexity is nothing but order of n. Okay, this means we are traversing, or the program grows with the input size in linear time. Okay, so if my program size is 1, my execution will be 1. If my program size is 10, my execution will be 10. But if my program size is 100, my execution time will be 100. Execution time is nothing but the number of times the code is running. Okay, so when we calculate time complexity, we're calculating how many times will my statements be executing. Okay, so in here, if you see, let's do an example of linear. So for int I is equal to 0, I less than n, I plus plus. Okay, logic. Okay, so let's say there is a logic which is of order of n, order of 1, sorry. Let's some assignment or something, ARR of I is equal to x dot something. Okay, something. So let's say this is the logic, or this is the program. So this is taking a constant time, order of 1, but this entire loop is running n times, so it will take order of n. Okay, that's how we say. So our main idea, guys, in time complexity is to understand how many times my statement will run. Okay, or how many times my statement is linked with the input, such that if my input grows, how many times will my statement run. So if you see, if my n is growing, so if my n is 1, this will run 1 time. This loop will run 1 time. If my n is 100, it will run 100 times. So this is linearly bounded. So as we are growing, so if we draw a chart, as we are going, my execution time will grow, or something like this. So this is linear, and this is very simpler. This is the simplest one to understand. Okay, let's talk about logarithmic now. Before logarithmic, okay, let's talk quadratic first. Okay, so it will be a little easy to understand. So now if you see, this operation was taking order of 1. Okay, so but if it is taking order of n, okay, let's say there is some other logic, let's say, which is taking order of n, let's consider. Okay, so now in this case, the inner logic is taking order of n times, which is again bounded by input, and then the outer logic is taking n times. In this case, it will become n squared. Okay, so n into n becomes n squared. So any polynomial which is of higher degree, we say is a quadratic, so it could be n squared. Similarly, if there is a logic which is running for n squared times, and then this overall for loop is going n times, we say it n cube. Okay, it will be something like this. Okay, something like this. So this is n square and n. So quadratics are simple. So let me give an example of quadratic as well. So let's say I have a loop for int I is equal to 0, I less than n, I plus plus. For int j is equal to 0, j less than n, j plus plus. Try to understand, guys, because time complexities are an important concept and you should know how we can do it. Okay, logic and some constant time logic. Let's say swapping logic, something like int temp is equal to x, x is equal to y, from y is equal to 10. Okay, some constant time logic. Okay, so this is my program. So if you see, this entire thing is a constant time operation. So it will, no matter how big my input is, these lines will only take order of 1. Okay, but my this loop, if you is running from 0 to n, that means as my input grows, this for loop will grow. If my input is 1, it will run 1 time. If it is 1000, it will run 1000 times. So this is bounded by my input size. So I will say it is order of n. How? Because it is linearly bounded. Okay, so this is n, and there is one more loop which is also running n times. Okay, so if you see, this is one more loop which is also running n times. So if my output is 2, for first time I will execute 2 times for index 1, and then for index 2 also will execute 2 times. So 2 into 2, 4. So this is nothing but n square. Okay, 2 square. If my input is 3, so I will run 3, 3, and then 3. This is nothing but 3 times 3 times 3 times, and 3 plus 3 plus 3, 9. Okay, this is nothing but 3 square. Okay, so as my input is growing, my execution, or the number of times this statement is executed, is also increasing simultaneously. So if you have to calculate, it is n into n square. So it will be n into 1. This is a constant time operation. So it is n square. Okay, and now let me give you one more loop. Now you have to tell me what will be the time complexity of this thing. Let's say for int I is equal to 0, I less than n, I plus plus. Int j is equal to 0, j less than I. Notice here j plus plus, and there is some constant time operation. So what will be the time complexity of this program? Tell me. So check the outer loop, check the inner loop. Inner loop is running. Is it bounded by n, or is it bounded by something else? Okay, let's see. Guys, try to respond in chat. So, okay, let's try to understand it with a practical example. Let's say n is equal to 8. Well, 8 will be very big example. N is equal to 5, let's say. Okay, so now my outer loop is at 0. Okay, it will run 1 time. For 1, it will run 2 times, 0, 1. Okay, for run, it will, this is outer, this is inner. Okay, and this is count, let's say. Count is 1. This is running 1 time. For when it is at 1, it will run 0, 1. It is nothing but 2 times. So it is 2, it is 0, 1, 2. Okay, it is 3. For when it is 3, my loop will again start from 0, 1, 2, 3. Okay, so this is kind of 4 times. So now it is less than or equal to, let's say. Okay, if you have confusion, 4, it is 0, 1, 2, 3, 4. Okay, so now it is 5. 5 is less than 5, so it will break. So if you see, it is executing 1 plus 2 plus 3, whatever the summation it is. Okay, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 15 times. Okay, it is nothing but a summation of all this time. So for the first time, it executed one time and 3, 4, 5. So if you notice a pattern here, this is nothing but a natural series number. Okay, so for n is equal to 5, it is nothing but 1 plus 2 plus 3 plus 4 plus 5. Okay, till we get 5. So this series we have already seen. That means in mathematics, we already know this series. This is nothing but n plus n minus 1. So till 1. Okay, 1 plus 2 plus 3, so on till we reach n. This is nothing but a summation of n, which is nothing but n into n plus 1 by 2. Okay, so this is the actual time complexity. If someone is asking what is the time complexity of this logic will repeat n into n plus 1 by 2. Okay, now let's calculate. So when it n into n plus 1 by 2, it is n square by 2 plus n by 2. Okay, so now if you see which is the highest degree here, degree of polynomial, which it is having degree 1, it is having degree 2. So in here degree 2 is highest, so we can just skip this thing. Okay, so when it is something like this, we can just ignore it. So let's say it is n square by 2. Again, by 2 is again constant, so this is not bounded by integers. So in notation, if I have to explain, we can just skip 2 and the actual annotation. So it will be n square. Okay, this is how it is n square. Technically, it will be less than n square because it is n. This guys, please be on mute. So it will be less than n square, but it will be this is the actual one. Okay, if you are very much precise about the time complexity, this is the actual one. But when we discuss or when we say the notation, big O notation, we cannot say some big formula like this. Obviously, we can give, but it will make no sense. So we have to simplify it. So when we are simplifying, it becomes n square. Okay, so we can say that this time complexity is also n square. How is it n square? Based on this relation, this corresponds to this. Okay, clear everyone? So that's why computer science is very much related to mathematics, guys. So if you are good with maths, you will be automatically good with computer science. Okay, now let's talk about logarithmic time complexity. Let's say we have a similar loop. Okay, let's say I have a for loop which runs something like this. So for int I is equal to 1, I less than or equal to n, I is equal to I into 2. Understand this. I'm multiplying by 2 every time. And then there is a logic of constant time. Okay, so let's say this is a thing. So how will you calculate the time complexity? So this is bounded by n, but it is going n by 2. Okay, it is not incrementing linearly, but it is having some logic here. So try calculating the time complexity of this. So what will be the time complexity of this thing? Tell me, guys. Try to understand, try to trace down how many times this logic will run. So time complex is nothing but understanding how many times this logic will work and how is it related to n. Okay, how we can relate it to n. Okay, let's see. Let's trace it down first. Okay, let's say my n is equal to 20. Okay, let's say it is n is equal to 20. So I start from 1. Okay, it is executed one time. Okay, then then the I becomes 2, then I becomes 4 because I'm multiplying with 2 every time. Okay, 4 2s are 8, 8 2s are 16, 16 2s are 32. Okay, it breaks here. So how many times does my logic is executed? 1 2 3. Okay, so it is how much? 5 times. Okay, so now if you see, this is nothing but okay, now if I count it, it is 5. Let's say if it is something else, it will be something else. Okay, so if you notice a pattern here, so it is nothing but 2 comma 0, it is nothing but 2 comma 1, it is nothing but 2 comma 3, it is nothing but 2 comma 4, it is nothing but 2 comma 5, 2 comma 2, 2 comma 3, 2 comma 4. Okay, 2 comma 4 is nothing but 16. So if we keep on increasing our for loop, it will run. If so, we know that it is stopping at 5. But if you don't know, let's say number is something huge, but it will stop at some k value, correct? So it will stop at some k. So the last value will be nothing but 2 power k. Okay, so it will be something like this. And how many times it is executed? This k times. So now we have to say, so 2 power k is equal to n, because this is nothing but my n will be somewhere on that point. Okay, so it will breach my n value. Okay, so if you see here 32, it is breaching my n value, so I'm just giving is that 2 power is slightly more or less equal to n. Okay, so this is the thing that we can understand through this series. So 2 power k is equal to n. Okay, so now we are interested in k because we want to know how many times it is executing. K is nothing but, if k here was 4, that means it was executing 4 times. Okay, 4 plus 1 times. Okay, more or less the same. Okay, and so we are now worried about k. So how do we find a k? If we have a equation like this and we want to find k, it's simple math. We have to pass 2 here, so k will become log n to the base of 2. Okay, so if you see, it will be the formula with this. So now we have k, that means my time complexity is also log of n. Okay, to the base 2. Why to the base 2? Because every time it is incrementing according to the base of 2. So if it was to be 3, it will be log 3 to the base log of n to the base 3. Okay, understand it. Okay, in computer science, mostly when you're discussing these problems, it will be always log of base 2 only. It is expected it will be log base 2, but there might be a case where you can have log base 3 or log base 4 depending on the problem set. Okay, a reason why it will be 2 in most of the cases, because most of the problems you will be either making binary decisions. Okay, either go left or right, or divide in this state or this state. So binary tree, if you see, go left tree or right tree. Okay, and even in the bits, if you see, there are only 2 bits, 0 and 1. So in most of the cases, in most of the problem, it will be log base 2, but there might be case where it will be log base 3. Okay, so this program will run only log of n times. Okay, clear everyone with this thing? Okay, now I'm giving you one more problem statement. Now you have to say me what is the time complexity of this approach. So let's say for int I is equal to n, I is greater than or equal to 0, I is equal to I by 2. Logic. Okay, constant time logic. Order of one logic. Tell me the time complexity of this approach. trace it down. Try to trace it down the way we did for the previous problem. Start with some big value of n and see how n is progressing as the loop is executing. Trace it down, guys. So let's say my n value is again, let's say 16. Okay, so now we start from 16. This is my I. Okay, I is at 16. Okay, then it becomes I by 2. This is 8. This is 4. This is 2. This is 2 by 2, 1, and this is 0. This is where we fail. Okay, so this is the number of times we are executing. So it is 1, it is 1, it is 1, it is 1, it is 1. How many times? 1 plus 1, 5 times. Okay, so it is 5 times, right? So try to get a pattern. 16 is nothing but 2 power. So we'll try to go from here. So it is nothing but 2 power 0, 2 power 1, 2 power 4, 2 power 2, 2 power 3, and then this is 2 power 4. Okay, that's the same logic. So here we are going n by 1. Okay, then it is n by 2. This is n by 4. Then n by 8. Every time we are dividing or by my I with powers of 2. Okay, so every time it is like this. So if you see, so first it is 16. This is nothing but n by 2 power 0. Then it has become 8. This is nothing but n by 2 power 1. It is not. Then it becomes 4. It is nothing but n by 2 by 2. Okay, so it becomes n by 4. Then it is 2. So n by 4, whatever the previous value is, again dividing by half. So it is n by 8. Okay, this is nothing but n by 2 power 2 square. This is n by 2 cube. Okay, so on. So if you notice, we continue the same logic. Okay, and we go till this point, till we reach 1 is equal to n power 2 power k, n by 2 power k. Okay, again the same logic. 2 power k comes here, and this is n. So k is nothing but log of n. Okay, so when k is log of n, our time complexity is also order of log n. Okay, this is how the time complexities are done, guys. So if you notice here, there is an important thing to notice. Every time we are dividing our n by 2. Okay, so we started with 16, then we divide by 2, then we divide. So if we have to draw a series, first n, then n by 2, then n by 4, then n by 8. Okay, so on till we get n by 2k. Okay, which is nothing but equal to 1. So till this series. So if the series is something like this, we have seen this. Just we have seen the proof. It is log of n to the base 2. Okay, so this time complexity is also log of n. Any questions? Okay, now let's try to relate this series. So okay, we have seen logarithmic also, log of n. We have seen quadratic also. Is nothing but n square or n cube or something else. Okay, so an exponential is nothing but 2 power n or 3 power n. How do we get 2 power n, 3 power n notation? Okay, let me give you a quick brief. We will not discuss in details. So let's say there is a program, mostly in backtracking and all those cases where we are brute forcefully going through all the decisions, then we'll have. Okay, let's say we have to make we have to find out all the numbers that could be found by 3 bits. Okay, 0, 3 bits. So 0, 0, 0, then 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1, 1. So these are the numbers that we can make through 3 bits. So this is nothing but 2 power 3. Okay, where 3 is a number. It is nothing but 8. Okay, 2 power 2 is 4, 4 2 is 8. So if you see 1, 2, 3, 4, 5, 6, 7, 8. So in this case, when we are generating all the combinations and all, depending on the input size, our program will execute. So let's say this to generate this thing, it is taking one execution of a particular logic. So for generating all of these 3, it will take 2 power 3 combinations, executions. So if my n is growing, my time complexity will also go. Okay, so this is 2 power n. So this will mostly occur in backtracking and all. We will see those things in later, but backtracking the concept later. But for time complexity wise, there is also exponential time complexity, which exponentially goes depending on the n value. Okay. So if there is some other logic, so it will become, so now that we have only 0, 1, that's why it is 2. But if there was some other 3, if so this topic is taking 2 power 3. Why? Because this particular bit can only take 2 values, either 0 or 1. That's why it is taking 2. So if it could take another value, let's say decimals, you know what binary system and decimal system, right? So in decimal system, if you want to take, that means this bit could take 10 values, then this time complexity will become 10 power n. Okay, depending on the program, our time complexity will change, but and eventually this 2 power n or 10 power n something is nothing but exponential time complexity. Okay, so that is here exponential time complexity. So with this we have completed our analysis of time complexities and all. So now let's see which one is better, or what is which time complexity is better than which. Okay, so if I just try to clear everything. Okay, so the first we will try to solve our time complexity. So order of 1 is the most preferable because it is a constant time operation. So order of 1 is always preferred. If not order of 1, then comes order of log n. Okay, and then if not log n, then comes order of n. Okay, if not n, then will be n log n. The log n value will be something like 1.2 or 1.3 something. So x into 1.2 will always be more than x. That's why n log n is something more. And then it will be n square. Okay, then n cube, so on, quadratic. And then comes exponential. So it is order of 2 power n. Okay. And the worst, even more worst, it will be n factorial. Okay. So even more worse. So this is how the sequencing is, how the time complexity is. So we start from in this order. So if you're getting a solution of n cube, no one will ask you to solve a solution in n cube, n power 4, n power 3. So if you're getting a solution in n square, we will always try to get it less than this. So there will be a follow-up question which can ask you to solve it in less time. Less time is nothing but these annotations. This is less, this is huge. So there is actually a chart we will try to see. So time complexity chart. You can see this thing. So this is order of 1 and n log n. They are mostly similar, but 1 is more preferred. And then n log n squared, 2 power n if you see exponential, then it is factorial. Okay. So anything beyond in this range, n log n range, if you see, this is kind of okay. This is, if you see, fair enough. Okay. But this n square and all, these are horrible. Again, this is according to this side, but remember this in mind that what are the priority of the time complexities according to the execution time. Okay. Okay, with this we have seen. So now let's talk about binary search. Why is it a log n? So if you see, if my input size is 4, so if my input size is 10, Okay, I first get the middle value. Okay, that means my overall range is 10. Then my overall range becomes 5 because we are dividing our half. So if my array is like this, I'm checking my 10. Then I'll be then I'll be searching either this half or either that half. That means my range is becoming 5. That means it is divided by 5. Then it becomes 2. Then it becomes 1. Okay, something like this. So again, this I started with 10, but if you start with 8, you will understand. Let's start with 16. So it is 16. Then it becomes 8. Then it becomes 4. Then it becomes 2. Then it becomes 1. Okay, this is how many times it is executing. Okay, so if you see, this is nothing but how many times? 1, 2, 3, 4 times, 5 times. Okay, 1, 2, 3, 4, 5. So this is, as we have seen, this series is nothing but log of n series. So we'll calculate. There is we can also do calculations based on log. So let's say log calculator. So log of what was it, 16 to the base 2 will give us 4, I think. Yeah, 4. So here it is 5. So this is nothing, almost equal to 4. So if you increase this value, let's say if you give 32, it will give you 5. Okay, so seal of the values you have to take. So even in this case, we might not enter the loop, we can just exit it depending on it. So this is nothing but log of n series. So let's say if there is a bigger number, let's say if there is 189, something like this, 7.5. So when you are saying 7.5, you have to take the seal of this number. So it will run 8 times. So if my input size is 189 and I have a logic which is performing on order of log n time complexity, so it will my program will run 8 times. Okay, or my statements will run 8 times. So that's how we calculate time complexity. Time complexity is nothing but how many times my statements are running. So if my input size is 189, my statements will run 8 times, which is nothing but log of n. Okay. Any questions till now? So if you see, here we are always checking mid and low, and depending on it, we are taking this. Okay, there is one more catch here. One catch regarding this statement. Can someone say me what? Okay, I'm removing this thing. We have covered all this time complexities and all. So I hope by now you are very good with understanding a time complexity, how to calculate time complexity, how to analyze time complexity. Even in recursion problems also, we have to understand how many times the function is repeated. Okay, if it is repeated n times, it will be order of n. If it is repeated log n times, it will be order of n log n. Sorry, order of log n. Okay, now let's see what is the problem with this line. Can someone point out what is the problem here in this line? So the problem here is if say let's say the high is very high, okay, some value which is very close to 2 power 8, okay, 2 power 8 or 2 power 4, depending on the compiler, we have 4 bits or 8 bits memory, right? And this is somewhere near 2 power 2. If we are trying to add these two, my integer number will go beyond my integer range. Okay, in this case, this logic will fail because we are adding two huge numbers. Okay, so we cannot add two huge numbers. So let's say my integer range is somewhere around 65,000. Okay, the 65,000 is the last integer number that my compiler can hold. But we are trying to add something like 40,000 plus 40,000. Okay, if you are adding these two numbers, my resultant number is 80,000. So 80,000 is obviously greater than 65,000. In this case, my integer cannot hold. So when my integer cannot hold, it will go to the negative side and it will go beyond the bounds. Okay. In this case, this logic will fail. Okay. So Again, this is very tricky thing, but most of the online compiler, online programs will fail because they write or they give you the inputs in such a way that it will test all your constraints. So in this case, how can we find the middle value? So there is an alternative formula here. So we can just say that low is low plus high minus low by 2. Okay, this is the alternative formula. In here, if you see, there is no chance of going integer over bound, because if you see, we are adding plus. Okay, so you might ask, but here there is still plus, but the next number is obviously not more than the integer bound. So if you see, we are doing minus, so this will obviously lead to a number which is less, which is small, and this cannot go beyond the bounds. How is this formula working? Let's say the low is 5 and high is 10. We have to find some number in between, that is 7. Okay, so what we were doing previously is we were doing 10 plus 5 by 2, that is nothing but 15 by 2, this is nothing but 7.5 something. Okay, so we were getting 7. But here if you see, we are directly adding. But now what we will do is, we will do 5, we'll try to get the middle of this range. Okay, so 10 minus 5 is how much? 10 minus 5 by 2. 10 minus 5 is 5 by 2. 5 by 2 is nothing but 2.5. Okay, so 5 plus 2.5 is 7.5, the same thing. But we are avoiding this entire addition. We are just calculating the middle of this thing, and then we are adding it to the low. Okay, middle of this thing plus low will give us a middle index. Okay, so you can optimize your program by writing this logic. It will not optimize in the sense, not optimize time complexity, but to avoid the corner cases. Okay, so it will be high minus low by 2. So this is all about searching, guys. So we have seen linear search and binary search. I'm giving you the problem statement in chat. Keep a note of it. The last few lines got missed, so I'm sending the main program again. Any questions, guys, till now? Okay, so now let's see a few problem statements. So this is the first problem statement. So this is again a lead code problem. You can try solving it in lead code. Okay, so this is an easy level problem. So try to understand this. Given a sorted array of distinct integer, okay, it is having distinct integers, and the target value, return the index if the target is found. If not, return the index where it would be inserted. So till here we have seen return the index where the target is found. So we have seen how to use binary search and all. But it is also saying that return the index where it would be inserted. Okay, if the element is not found. So the question is, if my array is like this, 1, 2, 3, 5, 6, 7, and we are searching for 4. Okay, so we start looking with the middle value here. This is the mid, so this is not. So we'll try to search this part in this range. This is the mid value. Again, we have to search this part, so we will search in this part. So 5, again we'll try to go this one, but we didn't find. So eventually 4 should be inserted in this position. So the index of 4 should be 0, 1, 2, 3. So it should return 3 as an output. Previously we were just searching for it, and if it is not found, we were returning -1. But now if it is not found, we have to return the index where it should be inserted. Okay, so this is the question, and you have to write a time algorithm which runs at order of log n times. Think, so how do you solve this problem? Think of a brute force and think of a optimized solution. Did come on guys, be responsive. Yes. So I've seen there is a logic in the chat which is correct, but it is not login. So try to improvise it. Thing guys, try to do it in a brute force way. If not, try to optimize it. So the very simple solution would be we can go in a linear fashion. Okay, the moment we see the number which is equal to 5, equal to 4 or greater than 4, we'll just return that index because it is saying that given a sorted array of distinct integers. Okay, so if we start seeing, so 1 is equal to 4, no, 2 is equal to 4, no, 3 is equal to 4, no, 5 is equal to 4, no, but 5 is greater than 4. So this should be the actual index. So I can just return this index. So this way linearly I can do, but it will be order of order of n. Okay, so the question was to do it in order of log n. It's a very simple solution. So now we will make use of binary search because it is already sorted. So in binary search, we know that it is 1, 2, 3, 4, 5, 6, 7. Let's say it is 0 and 1, 2, 3, 4, 5. So the answer should be 3 because in this 3 position, my 4 should be there. Okay, my target value is 4. Okay, we will start linear search, binary search. 3 is not possible, so we try to search here. So 6 is not possible. So now I'll try to go this way. So my start and end are here. Okay, so low and high. Okay, so now even the 5 it is not possible, so I have to do what? I have to return, means I'll try to go this side. So when I try to go this side, my high will be coming here. Okay, so high will be mid minus 1 if you remember. So whenever we are trying to decrement, or when we're trying to search on the low side, it will be a high that is getting affected. So when I say high, my obviously now my these things are going out of the context. So my high is becoming less than low. This is where we will stop. So if you notice, the moment I stop, my low is pointing to the correct index. Okay, so my low is pointing to the index where my 4 should be. So I can just simply return low. Let's try to find another example. 1, 2, 3, 5, 7, 5, 6, 7, 5, 6, 7, and let's say 8 is the target value. Okay, so this is start, this is low. Okay, this is the mid value, and this is not possible. So we come here. Okay, this is start and this is low. Now this is the range. In here, this is the mid value. So even this is not possible. This is start, this is low. So now if you see, this is my low, this is my end. Okay, so now even this is not possible. So I try to go to the right side. When I try to go to the right side, I increment by low pointer, if you remember. Okay, so increment by low will be mid plus 1, which is nothing but my low will come here. So okay, so this is nothing but, again, if you notice, my low is pointing to the correct address. So if 8 should be inserted, it should be inserted at this index. So I can, if by binary search I can do it, and I can just simply return. If I find the index, then it's very good. I will just return the middle value. If I don't find the index, I will return the low value, because low will always point to the index where the value should be. Okay, so if you see, I can just simply update my program. Okay, so I will return this. I'll just update it. Okay, found says should be at, okay, find index binary. I'm sending in place of -1, I'll just return low. So because my low will be the value which will be holding the index of insertion. Okay, so if you see this, let me give a problem statement. So let's do the same thing. Let's say what was array size? 6. So my array size was 6. This was my array. Okay, 5, 6, 7, and I'm searching for 4. So now he'll not find 4, but my 4 should be in this index. So 4 should be at 0, 1, 2, 3, third index. Okay, correct. So now let's say if it is 3, so 3 is already there. So 3 should be, it should return the index of 3. So answer should be 2. Okay, so and it is working. For 0, it will return 0th index, and for 8, it will return 7 as an index, 6 as an index. Okay, 0, 1, 2, 3, 4, 5, 6. Yeah, 6. The 6 is the size, so last index is 5. So 5 plus 1, 6. Okay, so this is the solution. So I appreciate the solution, which was at least trying to do it in linear fashion. There was only one person who could say the linear solution. So the linear solution is very simple, guys. We try to go linear wise. So the moment we see a number which is equal to or greater than 4, we return this index. So if you see, I have to go linearly. So I'll not write that logic. You can understand it, right? So this is 5. So 5 is greater than 4. Let's say 4 is the target. 5 is greater than 4. I'll just return the index of 5. Okay, there is a question in chat saying that will it work? So I'm just putting this logic here. So can we do it in this way? We can add one more if condition saying that, but you have to remember that in these cases you are going mid -1. So there is a chance that you can go beyond the bound. So first of all, you cannot do mid -1. What if my mid is the last element? Okay, let's say 9 is the last index, and we are pointing, mid is pointing here. So okay, mid -1 you're doing, right? So let's say 0, and it is pointing here. So 0 -1 is -1, which will lead to out of bound exceptions. Okay, let's say somehow you have arranged to sort this also. Okay, even in that case, I don't think this will work, because let's say mid value is set as 7 and my target is 8. Okay, so mid is target is greater than mid, and it is, I don't think that this should work, because it is distinct values. This should work, but try it out. I mean, so yeah, you can try this logic, even this you can try it, but make sure that you figure it in this case. Okay, where if my mid value is 0, you're doing 0 -1. So you have to try out that condition. Okay, just try out. So everyone got this solution? Any questions? Yeah, so there is one counter question regarding it. So when 7 is less than 8, then low will be mid plus 1. Is this a question regarding to the logic that we just discussed, or is it the question regarding regarding the solution that we discussed, the overall solution? So this is the logic I am putting in the chat. Try to go through it. Okay, let's move on to the other question. So the next question is finding the first and last index in a sorted array. Again, this is a lead code problem. You can try it out. Okay, so given an array of integer nums, given array of integers sorted in ascending order, find the starting and ending position of a given target value. Okay, if the target is not found, return -1 you must write the logarithm in log n complexity. So basically the question is saying that you might have a integer number sorted in an ascending order but can have duplicates. So 1 2 3 3 3 3 3 and then 4 4. Okay, and if I say 3, so what is the starting index of 3 and what is the ending index of 3? So starting index of 3 is 0 1 2 3 4 5 6 7 8. Okay, so the starting index of 3 is nothing but 2, ending index is nothing but 6. So you have to return this as an output, 2 comma 6. You have to return the integer. So integer array. So how will you solve this problem? Can I use binary search or should I use linear search? Okay, so what will be the answer, guys? How will you do it? Even if you are doing in binary search, then how? So till now we have only seen binary search for distinct elements. That means all the elements are distinct. But in here, how will I know? Let's say I am searching for 3. So in the middle value itself is 3. So I will, so according to our logic, we have to stop here. But I should not stop. I should go this side and that side. So how will I do this? So will I go this side, that side linearly, or what is your approach? Okay, so let's discuss solution. If you notice, the first thing that we can do, so whenever a problem is given to you, think in a brute force way. That is the first approach. Okay, so try to get a solution, working solution. So he is asking me to find the first and last index of 3, and it is sorted. So it is very easy. I'll just go linear wise. Okay, the moment I find 3, so that is my starting index. Okay, I just point store it, and I'll continue my search. The moment I find a number which is greater than 3, I can just decrement and get the ending index. Okay, with this I can get, but this is nothing but a linear solution. It will take order of log n time. Oh, sorry, order of n time. Okay, because we don't know till what point you have to go, and this end could be at the very end also. So this is how we can do it. And let's say the corner case, let's say 3 is not found itself, and then we can just initialize start and end as -1, and this will never change. So our program will still work. Okay, so yeah, so let me write the linear program also so that you understand. And it is saying that you have to return an integer array. So if you see the C Java code, it is nothing but you have written an integer array. So we will use the same thing. Let's use the same signature. Okay, so this is the number. So I can simply say int start is equal to -1, int end is equal to -1. For int I is equal to 0, I less than nums dot length. If my ARR, sorry, my nums of I is equal to target and start is equal to -1, that means start is still not initialized, then I will say start it is equal to I. That means I'm setting up the I. Okay, if my nums of I is greater than target, that means I have reached a point where I'm going beyond the number, and my start is not -1, that means there was a start point. Okay, this condition is important because let's say if the array, what if the array is something like this, 6, 7, 8, 9, okay, and we are searching for 3. So obviously 6 is greater than 3, but I cannot assign the end value as 0 minus 1. Okay, I cannot do it. So that's why I'm just searching. Before setting the end, I am checking whether the start is there or not. Okay, end is equal to I minus 1. And then I can just break. Okay, once I set this, I will break it. Okay, done. So now what we can do is return a new integer array with this value start, comma, and okay. Let's test this. I will say yeah. So I will, what is this search range? Search range of ARR, comma, K, search K. So let's do the same thing. Let's say the 5, 7, 7, 8, 8, 10 is it, right? 5, 7, 7, 8, 8, 10. How many numbers are there? 1, 6 numbers. And what should be the output? Let's say search for 7, I'm saying. I'm saying 8, right? So let's do for 8. I minus 1. Non-static method, come on. Okay, 3, 4, and the answer is also 3, 4. So this is working. Okay, so if I give some other values also, let's say 4 is not there, so you should return me -1 and -1. He is returning, and if I give 11, even in this case, you should return -1, -1. Let's do one last test. Let's say 10. Okay, for 10 it is saying 5 and -1. Okay, so whenever I'm doing start, I have to also initialize and Okay, so end is also 1. Now it will work. Okay, 5 comma 5. So understand, this is my linear logic. So linearly, so this will run, this will execute order of in the time complexity of order of n. But the question clearly says that you have to do it in order of n log n. So you have to do it in log n. So if not there, just returning end start right. I didn't get the question. Please reframe the question again. Okay, so just putting in the chat for your reference. Okay, but now we have to optimize it so that we are doing it in log n. So try to introduce binary search here. Let's understand how we can do it. So let's say if you are doing this, we can continue our search. Let's say we were previously stopping till we get to the till we get a middle value as target. That is where we are stopping. But now we will not stop. We will try searching even in the left side. Okay, till we don't find it. So we will search here. Okay, then you will try to search in this part where it will fail. Okay, this is the point we can note it. Okay, this is the last element or last index where we found 2, 3. Similarly, we will find it in this side. Okay, so if we can change our binary search in a way that it searches for the left and right side, so we can get this algorithm in order of log n time complexity. Okay, so again, there was one more solution, that why don't we get the index? Okay, we find it and we go linearly this side and this side. So again, if you see this side, it can go till n, and this side also it can go till n. So overall, our time complexity will be n in that case. So we are not achieving log n time complexity. So for that, we have to use pure binary search only. So let me write this logic again. So if the element is not there, we are just returning the end and start value. That's it. Yeah. So if you see, the start and end are initialized at -1, expecting that the element will not be there. So if let's say this for loop executed and we didn't find, yeah, this start and end will still be -1 and -1. Okay, that's why it is working. Okay, now let's see how we can do this logic. So first of all, okay, so this is my from binary search, right? So what I will do is I'll just copy this logic. I'll paste it here. Okay, so I have low, high, and this thing. Okay, so we are doing this. So if my ARR of mid is target, I was returning this thing. Okay, I was returning, or I was stopping the loop, but now I will not stop. Instead, I will continue. So how do I continue is I will set the start. Okay, so start is equal to mid. That means at least till this point we have a start value. Then what I will say is I'll go to the left side. So how do I go to left side? I'll decrement the high value. High is equal to mid -1. Okay, so this loop, when it finished executing, it will have the start value. Okay, so loop to get the start order of log n. Okay, similarly, I will execute or return rerun this loop to get the mid value, end value. So in end, I have to go right side. So how do I go right side? I will increment the mid value, low value. Okay, so this is done, and this is also done. Loop to get the end. Okay, and then it will return start and end, but also we have to reinitialize these values. Yeah, so this is it. I'll change it to ARR because everywhere it is ARR. Okay, so this logic will now work. So now let me give it a. Okay, 7 is in 1, 2. Let's do 8. 8 will be in 3, 4. Yeah, let's do 5. 5 will be in 0, 0. 10 will be in 5, 5. And it will work for all the negative cases also. Let's say 90. Okay, 90 is not there in this array. So it will be -1, -1. Okay, so if you see, we have optimized our approach, saying that to find it in log n. So now you might say that, okay, previously we were using n, but now we are using two log n approaches. So overall time complexity will still be less than n. So if you see n versus log n for first time, okay, this is for getting start and this is for getting end, log of n. So if we combine, it will be 2 log n. 2 being a constant, we can just ignore it. So it will be order of n versus order of log n, and clearly says it's, we know that order of log n is less. So we are solving it in log n. Clear everyone? How did we do it? So this will be log n. The only trick here is, guys, that previously we were stopping our search the moment we get the middle value, but now we will not stop and we'll continue our search even if we get the mid value. The moment we get the mid value, we are just storing the reference. Okay, that this is the possible start or this is the possible end. Okay. Okay, so I think with this we are over the time now. So the next session we will discuss sorting algorithms, different sorting algorithms, how are the time complexities calculated for them, and all those stuff. Okay, let me know how was the session, and let me know if you have any questions. Okay, so try. I mean, I've already given you this logic. So try solving few problems on binary search for the next 2 days, and the next session we will see sorting. Okay, I don't see any questions in the chat, and we are over the time, so let's finish this session. Okay. Sir, why start is mid? Start is equal to mid because we are storing the reference. So eventually we need the index of the target. So whenever we are meeting the target, I'm just storing the target. How do I store? I store it in 2 variables, start and end. So whenever my ARR of mid is equal to target, I just store the target in start and mid. That's why start is equal to mid. Okay, guys, so let's meet on the next session. Next session will be on sorting.